Okay, so now we are going to look at another rule, which we are going to call the quotient rule. Now, this rule actually kind of derives itself, funny enough, from the product rule. And that kind of makes sense based on, all the things we've talked about for a long time, which really, multiplication and division are really just two sides of the same coin. You can look at division as multiplication, and you can look at multiplication as division, and that's really all this is right now. But the quotient rule is when you have two functions being divided by themselves, or being creating a quotient, excuse me, and that value is some other function. So the example would be, f of x equals g of x divided by h of x. Okay? Now, there's a little kind of mnemonic, little kind of, tune or whatever, I don't even know what you call it, but that's used to remember this rule that I'm about to show you, because it looks complicated, but it's really not so bad, and it does make sense. You can derive it again from the product rule, so if you ever forget it, you can always go back and think about it, and I will make a video on that too, how you can derive the quotient rule from the product rule. But this method, this little kind of memory aid, works pretty well. I mean, and I think you might even have some fun with it for whatever reason. But we're going to start off, and we want to call one of the functions, we call this function up on top. We will call this one high. Okay? And we will also call this function in the denominator, we will call this ho. Okay? So you have high and ho. So high is on top. Okay? So what what the rule is in a general way, okay, so, if you were to write this out mathematically, you would have that your h prime of x is going to be h of x times g prime of x minus h prime of x times g of x divided by h of x squared. Okay? And then that looks pretty intimidating. Lots of stuff going on there. Well, we use this little mnemonic I wrote up here at the top. We use this as an aid to help us remember this kind of longer formula. And the way that is going to work is this. Okay? We have, and so we called them high and ho. So we start off with, it's ho, and then we have d high, ho d high, which d high represents the derivative of the high function or the top function, and then it's ho d high less than pi d ho over ho ho. Okay, so the way that you can remember this rule is just kind of this simple little, I don't know, yodel kind of thing, I guess, which is ho d high less hi d ho over ho ho. Okay, so ho d high less hi d ho over ho ho. All right, and the d represents the derivative of whatever function that it is that you're talking about. So you can see the similarities with the product rule, but you notice, okay, so why am I dividing by this function squared? Why is there a negative sign? Well, it all has to do with the fact that you have these negative exponents. The denominator here, the ho part of the function, has a negative exponent of -1 if we were to think about it as multiplication. So the other video that I will make will kind of explain how that works and all. But we need to use this rule in order to find our derivative. Now, again, the quotient rule is not always necessary when you are dividing things, but sometimes it is absolutely necessary to do, so you have to know how to use this rule. So I will skip to the next slide, and I am going to show you an example of how this could work. So if we have f of x, if that is going to equal, okay, let's say x divided by cosine of x. So switching it up a little bit. So x over cosine of x. There's no way I can rewrite this, so I have to go through this problem using the quotient rule. I have to. All right. So I need to identify my different parts of my function. So here, excuse me, I'm just going to skip back for a second. So I had, okay, so blue was high. Okay. So this is going to be my g of x, or we will call it, right, high. And then this is my h of x, or ho. Okay, so we've got those things. So we've now just got to put our derivative together. All right. So we need to also identify kind of the other parts of this function, which we've got our g prime of x. That is going to equal 1, and our h prime of x is going to equal negative sine of x. So it's important that we know if we keep that negative, it's going to change some things in our problem. So what we need to do is put this together. Again, remember our mnemonic, excuse me, which was ho d high less high d ho over ho ho. Okay, so that's the method that we have to do. And so these are, this is like the d high here. The d high and the d ho are up over here. So we're going to have f prime of x, again, it starts off always with ho d high. So I need the bottom function, the ho function, which is cosine of x. That multiplies by d high, which is the derivative of the high function, or g prime of x. That is 1. I always have to have a minus sign. Okay, so that's where the less part comes in. So you have ho d high less high, which is our top function, which is x. And then you have times d ho, which is the derivative of the denominator, which in this case is negative sine of x. And then we divide this entire thing by ho ho, which that is going to be the cosine of x times the cosine of x. Right. So now our main goal here is going to just be to simplify this function. And once we do that, again, we're finished. So 1 times cosine of x is just cosine of x. Then we look at the second part. So we have a minus x, or you can think of it as a negative x times a negative sine, which is going to create a positive x sine of x. And then we divide. Our denominator is cosine times cosine, so that is just cosine squared. And voila, we are finished. Okay, so that is our derivative. Now, you could mix this up. You could write this in a bunch of different ways. That's just kind of how trigonometry works. This is acceptable. This is fine. But it looks very, very complicated. But again, all you're really doing is taking simple derivatives, so little parts of our function, so the high and the ho, and we do the derivatives of those, and then it's just a combination of putting them together. So you end up with cosine of x plus x sine of x over cosine squared. Looks complicated, but little procedures create this very complicated looking formula. But none of the math is really that intimidating, so long as you can just take a simple derivative and put it together in this form. Okay, so again, just so that you know, and hopefully I've said it enough to where you actually can remember it. What you're going to want to remember is this little kind of phrase: the ho de high less high de ho over ho ho. It's kind of funny. It's really not so hard to remember. But it is very critical when we're trying to find derivatives, because sometimes there's no other way to find a derivative than if we use the quotient rule. So it is very, very key that we have this kind of in our toolbox, and we're good at applying it, because from, just once we move on from quotient rule, it will pop up in all sorts of problems And we're going to have to know how to do this in order to do anything with them, because you're going to have to take the derivative to do a whole lot of other work. It's not just about finding derivatives, it's about using derivatives to find and to make meaning of other things. So one more time, quotient rule is about the combination of the derivatives of our functions with the other parts of the functions, and but very simply, it's just ho-de-hi less hi-de-ho over ho-ho.